Hello.
Yes, I'm
Where did
here.
you go? Yeah, can you go to the next slide? Wait, where did this guy go? So breathe. To the next slide.
Guys, sorry for the technical issue. We'll be back in just a second. In the meantime, can you guys, just make sure you're following our Instagram and Telegram so that you don't miss any future updates. We'll share the link in the chat immediately.
Yeah.
Yes. So, are you all wondering how to choose a domain in technology to start your career with? So, don't worry. Like I told, we were standing in the same shoes, and now we have an idea about what domain we should go to and what skills we had to acquire for them. And we are going to share the knowledge with you guys as well. Yeah. Next slide. Yeah. So, the way this is going to work is we'll have a speaker speak about a particular domain, and you can put your doubts or questions in the chat, and we'll be addressing some of them over this meet itself. If your doubts are not clarified, you can put them on the Slack channel as well, to which we have linked in the chat, and or you can go to this particular link that is shown in the slide and post your queries there, and we'll be solving them either on this meet itself or on the Slack channel. Next slide. Okay, so the domains that we are going to cover are web development, app development, blockchain, and machine learning. And of course, if you have any questions regarding any other domain that you are interested in, feel free to post that as well. And we'll be trying to answer them to the best of our ability. So let's elucidate. So I'll be introducing the speakers now. So first for web development, we have Nimish Pongale. He is a software engineer at JP Morgan Chase and Co. And he also was a participant in Google season of Docs. And he has won multiple hacks from IBM, Manipal, JPMC, and more. And he is an alumni from Ramaya Institute of Technology. Next. Then for app development, we have Raghav Maheshwari. He is a associate software engineer at Oracle, and he is soon going to be a developer at Amazon as well. He was a finalist at the India Singapore Hackathon and the Smart India Hackathon 2020, and he is also a winner at Rapid, a global API challenge. For machine learning, we have Rohit Nagraj. He was the DSC lead before me, and he's currently a machine learning engineer at Graphene Services. He also won a International Asian Hackathon and the Smart India Hackathon 2019 as well. Finally, we have Aditya Gupta. He is currently a blockchain engineer at Brahma.fi, which provides products in decentralized finance space. He was formerly a software engineer at Amadeus, and he is a founder and former blockchain developer at Newborn Solutions. So we welcome all the speakers, and I'll be handing over to Saundarya now so that we could start with the web development.
Hey everybody. Without any further ado, join me in welcoming Nimish Bangali, batch 2021 RIT. As Kushal just said, he's currently working at JP Morgan Chase as a software engineer. He has been chosen as part of the Google season of Docs as well, where he's worked as a technical writer and project maintainer for Creative Commons. He's also on multiple hackathons. Having dabbled in many tech stacks, he's one of the best people to answer our questions on web development. So, hello, Nimish, and welcome to DSE's events.
Hello, hello all. In fact, it feels so strange to be called in as an alumni for all of this because I was also a part of the DSE RIT group and it has just been about a couple of years. So, yeah, it feels really special to be called on and asked to speak about something I absolutely love, which is web development.
So, to start off, before we delve deeper, can you just tell us what web development is in the first place?
I mean, going by the bookish definition of web development, it would be designing, creating, then actually developing, and then maintaining the website, right? And that is, again, like I said, the bookish definition. And then you have the famous front end, back end split in web development, right? And if you manage to do both front end and back end, then you can be called as a full stack developer. But let's just for a second not get into the technical definition, but approach it in a way that is understandable to everybody. So let's say you're trying to pitch your idea to somebody, you're trying to get them to basically you know vibe with your idea. So if you say, okay, I am doing XYZ, their first question might be, hey, do you have an email? Maybe you can email me the particulars of your idea and I'll go through it. Or, hey, do you have a website? And I will go through your website and see whether I like it or not, if I like the idea. So that kind of gives you how important web development is, because many companies want, even the startups want a website up so that they have something to showcase. So creating websites is an art, and I mentioned, right, designing, that is definitely an art, because websites that kind of catch your eye and are extremely creative in nature can often mean that you get an greater inflow to your website in general. And of course, developing websites is also very fun. Um, Together at hackathons, and even now, it never fails to surprise me that there are so many things that you need to take care of, right? And then I talked about front end, back end. Maybe we can delve a little bit deep into that in this interview itself. But basically, whatever is visible to the users who are using your website, you can call that as front end. And that would mean anything, any UI, yeah, right? Any user interface that the developer builds, that could be your front end. And then on the backend side, you have any database or any business logic that you write. That would, any server that you run, that could be your backend. Um, but one important thing is to always get your basics strong. In web development, especially, there are so many tech stacks, so many technologies, just making headlines like, oh, you should definitely be doing this. But to start off with, it's very important to, like I said, get your basics strong. So that would be HTML, CSS, JS. So get those perfect, get those at the tip of your fingers, and then you can proceed from there. um, but yeah, so I hope I've answered the what is web dev question. I'll leave the rest of the stuff as and when we get to those questions.
Thanks. So yeah, I'm sure all of the first years watching this would like to know what could or should a beginner's approach be, and are there any prerequisites?
So before I answer the prerequisites question, web dev is a most commonly gained skill, at least I would say, um, and it has a ton of resources available online, right? So, and let's just for a second think about it this way, that you can actually develop code, or let's call it the web dev code for everybody to understand, right within your browser, right? You can do something known as an inspect element, open the dev tools, open the console under the dev tools. So, and then you can execute any JavaScript there, right? So it should kind of give you a clue as to how easy it is to kind of get started with web dev. You can actually start from there. In fact, many of the folks here might know, what got me curious and involved into JavaScript was the Dino game that runs within the browser when you have no internet, right? So I used to play that for some time, and then I felt like kind of automating that whole thing, and I spent so much time, I don't know, countless hours just trying to get something out of that, and eventually I was successful in that. So uh, anyways, let's putting that aside, all you need is a kind of a working computer and the zeal to learn, right? And be ready to embrace the kind of vastness that web dev has. So yeah, the prerequisites would be something that is like, maybe a code editor, maybe having a browser so that you're able to Google stuff because there's so many resources. And of course, when I talk of all of this, internet connection, all of that, we get the idea, right? So there's not much of, I would say, installation and all of that that you would have to do when it comes to web dev. But if you proceed and decide to go deep into web dev, then there are a lot of technologies that come in. There are a lot of front end frameworks. There are a lot of back end, kind of structures that you would need to understand, and some of these applications can get fairly heavy, but that is again in the later phases. But to start off with, you don't really require a lot of uh, setup or anything. You can just keep googling and you will learn a lot that way.
Yeah, actually, speaking about the Dino game, I remember, I think in our first DSC meet, when you were part of the core team, you had actually showed us. And I remember that a lot of us were amazed. So, yeah, exploring is definitely an important part of web dev. So, thanks for pointing that out. Um, so, you spoke about, front end, back end, and the tech stacks. So, it's time to address that term, tech stack. So, what is a tech stack, and which tech stack should I, as a beginner, say, use or learn?
Right. So tech stack as the, I mean, let's go with splitting the word, right? I mean, I think it's already two words, but so tech again is just technology, and stack points to a bunch of things that are put together one after the other, right? And it so often happens in web dev that uh, to make a complete website from, an end-to-end perspective, you need to put stuff together. And that is how I kind of define tech stack, right? It's not sometimes just one library that will help you. You need a bunch of them. You have tons of dependencies on other projects. So yeah, that is what a tech stack is. And before you even jump into finalizing on a tech stack, you will need to explore, right? And why I say this is because once you kind of start exploring, you'll realize that there are similarities between tech stacks, that a majority of them have a lot in common. And even in fact, if you do one properly, you will be able to transition if you wish, right? Be flexible in that sense. So if you find something you like, great, go ahead, learn that. But if you feel stuck at any place, you should be always open to expanding your knowledge and learning something else. So you had pointed out the front end back end thing, so I'd like to expand on that a little bit. So I did mention that front end was the user interface. So on that side, we have so there's the UI side of it is JavaScript heavy, and JavaScript is of course a language. So that means you have a bunch of frameworks like React.js, Vue.js, and there's also something like Svelte. So uh, so within my firm, we at least my team uses React heavily. So and in fact, Svelte is used by companies like Razorpay. So the idea is that these stacks are quite in demand, and learning them will definitely help. And the way to appreciate these stacks is by actually starting off with HTML, CSS, JS, and realizing the problems that they have. Right. So you can't reuse stuff there. There are tons of problems, but once you switch to these frameworks, you start to understand and start to realize their beauty. So yeah, so that was me talking about the front end side of stuff. And on the back end, you have technologies like Node.js, Flask, Django, Spring Boot. So again, these are frameworks, right? Underlying, they're using on the inner side, they're using languages. So when I talk of React, Vue, and Svelte, they're using JS, right? And something known as JSX. But when I talk about Node.js, again, it's using JS. Flask is using Python. Django is using Python again. Spring Boot is using Java. So at the end of it, what I want to say is learning languages is important. A few languages that you know really well, and then you can kind of become a full stack developer if you wish, if you have that thing on your mind. And if you, let's say, put in front end and back end together and start to form tech stacks, you will get acronyms like MERN, mean, right, lamp, all of those. So MERN again is a very famous tech stack used in a lot of places. Again, if you want, I can expand it out. It's MongoDB, and React, and then Node.js and Express. Right? I mean, I think I messed up the order, but you get the idea. And the other thing is MongoDB, Express, Angular, and Node.js. So putting all of these together is what gives you those tech stacks. And it doesn't mean that you go on a on a kind of journey to learn all the tech stacks. You need to have the knowledge, a base level knowledge of everything, but if you really like something, go ahead and explore. So yeah, I hope this clarifies and kind of answers this question as well. So
Yeah,
yeah.
surely. So, to summarize, basically, you can get started with something as simple as HTML, then as you kind of understand the difficulties, you'll be able to appreciate it better when you move on to more complicated frameworks, right? Okay. So, expanding on the tech stack question, any kind of rubrics that you would suggest for picking a tech stack, because ultimately it comes to you choosing a tech stack for a given project, right?
Right. So you also talked about projects. So here's the thing. When you're working in a team, right, it's often important to kind of finalize on a tech stack and not kind of have clashes over it. So if you ask me about rubrics, I know people put out these charts, right? Which language has been most used or something over the years. And that chart is really unpredictable because, a few years down the line, the scene might be completely different. There's Web3 coming up. So, choosing on a tech stack, I think in the initial phases, if you like something, go ahead and, work on that, learn that. But eventually, you will start discovering that a few tech stacks are known for their stability, for their reliance. So that's when you can actually count on them to help you as well. So the industry standard, of course, speaks. Okay, you should follow this, this, and this because it's the best practice. But the journey to understanding why it's the best practice, why it's a really good tech stack, that'll make you understand a lot more than just picking the tech stack and going with it. So yeah, uh, I won't take any names of languages or tech stacks that you should certainly go with, but it is all about the exploring bit. And as long as you explore and as long as you learn, you always win. So yeah, that would be my answer.
That was nice. Um, so here's a question that's been playing on all our minds, I'm sure. What are the career growth and learning opportunities that you have as a web developer?
So here's what I'd say, right? Web dev is practically universal. because web has been around for a very long time and will continue to be around for, again, I don't know how long, but it will definitely be around, and it has plenty of scope. There's no need to worry about the scope as such, and the learning never stops because there are new front end technologies coming every day. There's a lot of improvement happening. Even let's say, let's say your website is taking about, I don't know, 500 milliseconds to load, right? And we call it something known as the first time load, FTL. So there are scopes to improve that as well, because for every millisecond that the user is not on your website, is, he or she is thinking about browsing to some other website. So the amount of improvements that you can do to a website at any given point of time are a lot, and that's why web dev jobs continue to exist, because there are always stuff coming up to improve this, improve that, make these changes, add this feature. So yeah, there's a lot of learning opportunity. And speaking of career growth, when you learn web dev, right, it kind of gives you the ability to switch to a lot of other technologies as well. And this is what I firmly believe, because let's say you develop the backend for a website, the same backend could be used for something else as well, right? The skills are kind of interchangeable, kind of, exchangeable. You can switch to some mobile backend work as well, because all you're developing as a backend developer are sometimes APIs, and those APIs can be consumed by your front end team. So um, yeah, that's why I kind of call web dev universal. You can definitely get started with web dev because it gives you the key to many other things as well. So speaking of key, right now within my firm I am working on an electron app, right? And electron is of course a desktop site, so a desktop app, my bad. So uh, did I have to undergo the desktop app learning thing? No, because Electron is a framework that is basically nothing but a browser window. Okay, it's a desktop app rendered as a browser window. So within the window, you have your it's practically a website, right? So I did not have a lot of prior desktop app development experience. But then, since Electron is a framework which accounts for this, right? It was built with this purpose that you could, develop something that like a website and have it show. So, yeah, I'm greatly thankful to learning web dev initially, so that I could apply those skills there. Um, and yeah, like I said, just tons of opportunities out there as a web developer, as a technical writer as well. There's so much that you can do with web dev. And in fact, because there's so many web developers around, there's a joke on Twitter that goes by, uh, everybody's just talking about web dev. Why isn't anybody else talking about something other than web dev, other than front end? So there are many people around. You can definitely talk to them. People who have made significant career growths by just having web dev as their main skill, and you'll find tons of examples, I'm sure. So yeah, that's my answer.
Yeah, actually, that makes a lot of sense about web dev, like opening up other doors also for you, making it easy for you to transition to other domains. That's definitely interesting, and yeah, it's always a good starting point, especially as a beginner. Um, so, do you ever stop learning with web dev, even once you enter the industry?
No, you never stop learning. And the main reason for that is there are technologies coming every single day. And it could be like, for example, right? Let's say you have a project that's very huge. Okay, that's kind of becoming unmanageable. So you have technologies to combat that sort of a scenario as well, right? If your build is failing and you don't know why, you keep googling, you keep learning. And right now the build works, but tomorrow it might not work. So you are just kind of continuously learning. There's no stopping that, and you have to embrace that learning. You can't sit complacent and feel like, I know everything. uh, and websites like Stack Overflow exist for a reason, because there are going to be bugs coming up every day, and you don't know how to solve them, because you know it's there are just so many things, right? um, and I'll give you an example. my project was, as in the project that I work with within the firm, it was getting kind of complex. It was really big in size, and the build times were also pretty insane. There were about for one particular repository, I still remember the build time was about 45 minutes to run the entire project. To So that was really something that was kind of pulling us down, because if a project takes 45 minutes to build, that is insane. So I actually spent some time on that, on how I could apply a library, right? And again, this sort of belongs to web development as well, because you will realize that at some point of time you will need to bring in some technology to solve some problem. So I bought in this technology known as Lerna, which is an orchestration tool. And because of using that library, I was able to kind of bring down our build times by a factor of about 40% to 50%. So our build times are halved, which is still better than having it double of that. So yeah, like I said, the learning never stops. You just have to keep learning every day. There are tons of things that you could do potentially.
Yeah, that's definitely true. With all of the advancements and like the fact that if you want an edge over anyone else, you'll obviously have to keep learning, especially in the domain of development. So there's one thing that you mentioned when we spoke about front end and back end, right? You spoke about slowly transitioning and becoming a full stack developer. So can you probably elaborate on that? Maybe explain to everyone what being a full stack developer is and how you can achieve it.
Right, that's a very good question. So uh, let me get back to the front end and back end thing, right? So front end development requires some amount of creativity. So if you like playing around with colors, if you like positioning stuff on a web page, and if you really like improving user experience, then front end development could be a thing for you. But if you are a logic oriented person, if you like seeing data flow from one place to the other, if you're curious how data storage occurs and all of that, then backend is the thing for you. But sometimes it might occur that you are kind of equally split between the two. And you really want to be flexible in the kind of roles that you receive, right? Because you might be there are companies that hire primarily for front end. Sometimes there are companies that primarily hire for back end. But if you're a full stack developer, which means that both front end and back end and you're equally comfortable, then that gives you that amount of flexibility in the kind of roles that you can accept, kind of do, right? So yeah it and it also means that you are kind of a one man army when it comes to developing websites at maybe hackathons or any other projects. And in fact, we have a one man army here as well, in the speaker panel, and he already knows I'm calling him out here. But yeah, there is so much that you can do being a full stack dev, because just because you know both primarily well. And it doesn't mean that you have to become a full stack dev. If you found your niche and you really want to say that, okay, I'm really good at this is exactly what I want to be doing, I don't want to be learning both, that is fine as well. It's really up to you to choose.
Yeah. So, finally, a very important question here. What, in your opinion, should we do to continue the process of learning and growth and focus on overall development as a software engineer rather than just staying focused on a single product, a single.
Right. Um, so a couple of things here. There are multiple things that are linked to software engineering, right? So being a software engineer is kind of giving you that luxury, that you're good at multiple things. And being a software engineer, as opposed to say a web developer, gives you that thing that, okay, I can do more than just building websites. I can possibly stray into the AIML side. I could stray into the any other app dev side, or maybe the blockchain side. So to be open to trying out new things is the key to being a good software engineer, I feel. Exploring, learning, right? Because our field is such that it moves at such a rapid pace. Today you see a stack being followed or being used heavily across, maybe 10 years down the line it may not be, right? But yeah, that's why it's so important to be knowledge hungry as well. Just keep learning. There's no end to it. But again, in this entire keep learning, keep going kind of philosophy, we kind of sometimes compromise in our health, and that is not something we should be doing. Yes, we are engineers, yes, we are software engineers, but uh, it's important at the same time not to kind of give up in the flow, kind of put yourself in the river and say, okay, whatever happens happens. uh, it, you have to kind of consciously take some decisions sometimes, when it comes to engineering in general, and of course software engineering. um, and to take those decisions, you can be open to talking to people who are experienced. Now, of course, I have been with JP Morgan, professionally employed for the past, let's say, 1 year, approx. So there are people who are way more experienced than me, and when I'm talking to you folks, I'm of course speaking from their experience as well, right? I'm not just making stuff up from whatever I know. uh, but yeah, the key to being a good software engineer is to be knowledge hungry and open to trying new things. um, and of course, the internet is a place where you can get answers to, of course, any single doubt that you have, and especially for web dev, because if you notice, web dev has likely uh, the most kind of span or uh, reach, and you can of course get answers to anything, even the smallest of bugs. The easiest way to do that is, if you encounter a bug, let's say while running your code, just copy paste that into the search bar. You're likely going to find somebody else who has faced the similar bug, and you can find maybe a GitHub thread, a GitHub discussion, or even a Stack Overflow answer that gives away what you want. So yeah, it is important to reach out to people, and yeah, that is that would be my answer again.
Definitely plenty of resources out there, especially for web development. So there's a question from Muskan, and she's asking if, when it comes to learning such technologies, what are some good resources that we can refer to as a newbie? Anything in
Right.
specific that you would like to recommend?
Yeah, I'll say something, and that is that I am a non-believer in roadmaps. I know that might come as a surprise, but I thoroughly believe that kind of everybody's path is different when it comes to approaching something. And following a roadmap can sometimes be restrictive, uh, and it's not kind of open or flexible in that sense. And let's say I share a to-do list right now. uh, it may not be applicable to you because you might go about it in a different way. But if you are into roadmaps, there's this website, roadmap.sh. So you can go over there, and it gives you a gist of nearly all technologies and the kind of roadmap that you can possibly follow. And for web dev especially, YouTube is a great place to learn because you have people, for example, Brad Traversy, who's making videos day in day out trying to explain to people what web dev is, and so many other folks, of course. I will not keep naming each and every one of them, but yeah, just great resources on YouTube. And apart from that, you have the uh, basically a lot of, not just websites, but also a lot of tools that can help you out. There are tons of Chrome extensions that can possibly help. Um, then of course, just experimenting in the inspect element tool that I just said, right, that I just mentioned a couple of sentences back. That can be really helpful as well, because that gives you a very easy way to debug and execute JavaScript. So um, yeah, and of course there are tons of courses available online as well. You go to Udemy, you go to Udacity, any other website, just tons of courses. There's just no end to it. But if you want any particular course, you can reach out to me. I can definitely help you out with how you can approach just learning in general better. But yeah, uh, I think that answers that question as well.
Okay, so we have another question here from someone who asks if React JS versus Angular JS, which one's better? I think I know what you're going to say, but
No, if you're going to force me not to be too diplomatic, then I can possibly say something.
yeah,
But
we'd like that, yes.
okay. Uh, so let's just put it this way that React.js is kind of just how do I even answer this? It's just a very um, of course, it's a famous question, and you have takers for both, right? But since I've been working in React for the past 1 year, I can definitely tell you that it's really easy to work with. We use React and Redux and a bunch of other stuff together, and yeah, React has always been kind of my first love. So I can vouch for React. But if somebody wants you to learn Angular, that is of no harm as well, because React and Angular are similar in quite a few ways. So if you do learn one, you can always transition into the other with some learning curve, of course. uh, and I think possibly learning Angular before can help you transition into React easily, but likely the other way is bound to be a little more difficult. So yeah, I think that was still diplomatic. Hmm. But
Yeah, but
that
I
was
guess
my
it answered a question well.
yeah.
So, yeah, another question here. Being a full stack developer, okay, so I think he's asking if being a full stack developer is worth it when a recruiter is hiring you, or is
So
it better in like when it comes to hiring, is it better if you're probably an expert at either front end or back end?
oh, okay. So we are kind of saying, is it better to be a full stack dev and have that
Yeah,
on your resume
in terms of
as
job
opposed to
prospects, yeah.
correct? So even if you're a full stack dev, right, it'll happen that you're slightly inclined to either side, right? So here, let's say on your resume, when you list out the kind of tech stack that you're comfortable working in or the skills that you possess, then there will be cases where it will be apparent from your resume that you're inclined to one side. For example, if you look at my resume, even though I've mentioned some of the backend skills that I have, you can see that is very front end heavy. So having a full stack kind of a thing on your resume might make it easier for somebody to hire you. But if that company has a lot of roles, like for example, if few companies have roles where it clearly mentions that you're getting hired for a full stack role, but some of the companies make that demarcation. They say, okay, you're getting hired for a front end role, you're getting hired for a back end role. So in that sort of a scenario, I think it is important to kind of have maybe, let's say, two resumes, one that is front end heavy, one that is back end heavy, if you will, and apply to them separately, because they are looking to hire people who are really good at something, right? And you could of course put in that full stack word and show your flexibility in learning and doing whatever. uh, but yeah, I of course, this is my first job, so maybe you should reach out to somebody who's more experienced and who can definitely answer your question to the point as to what I should be putting better. Let's say the word full stack, or should I, split it and put it that way? So yeah, that
Okay.
will be my answer.
So I guess with that we come to the end of this track. This has been such an insightful talk. A lot of very interesting takeaways. So thank you so much. Thank you so much for everything, Nimesh Bhaiya, for your time and for you patiently answering all of our questions. So I'm handing it over to Suraj, who'll be moving on to the next track.
Yeah, thank you, Sandarya, and thank you, Nimish. And if you guys still have any doubts on web development, you can always put it up in our Slack channel. I guess one of you guys can share the link to the Slack channel again, in case people haven't joined. And we shall move on to our next topic, which is app development. And No, it's my pleasure to welcome Mr. Raghav Maheshwari, who is our speaker for app development. He is currently working as an associate software engineer at Oracle. And without further ado, I would like to hand it over to Raghav Maheshwari. Can you please tell us a bit about yourselves before we begin?
Yeah, sure. So, as you know, my name is Raghav. I graduated from Ramaya Institute of Technology in August of 2021, and since then I've been working with Oracle as an associate software engineer, where I'm working on backend side of things. Basically, I deal with backend development there. So yeah, and other than that, I like to participate in hackathon stuff.
That's nice. All right. So, as I think the audience is aware that we recently put out our app, and maybe some of them are wondering how we even built it in the first place. So, making apps is app development. That's pretty straightforward. Now, how would a beginner approach app development?
Right. So yeah, that's a good question. Okay, and it okay. I'll cover it thoroughly. So first of all, let's talk about as to why app development. Like it's pretty straightforward. Like we have web apps, right? So why do we need apps? So apps kind of give users a real feel when they're using the app when they have it on device. Secondly, when you have apps, you can interact with a lot of the device APIs. For example, dealing with contacts, having various permissions, sending notifications. Those sending notifications is possible even on web nowadays, but when it is when you have it inside the app, like it gives a real experience to the user, right? So that is why companies have apps in the first place. Right. So now coming on to as to how a beginner should approach app development. So for a beginner to approach app development, first they need to decide as to what the target user is. Whom are they building for? For example, if they are trying to, they are really trying to build in native development side, then they should go for Android, or they should look for some cross-platform technologies. So if it is about how should they approach, they should decide their problem statement. Based on that, figure out what should the right tech stack be, and then start developing the app. So yeah, that would be my answer.
And I can also relate to the fact that on web, it's possible to send notifications these days, but making an app is better. And I think one clear reason for that is when you visit a website and it asks you if it wants to send you
Right.
notifications, everyone denies it. So
Exactly.
that impacts people a lot. So that's why apps are made. So that's a really good point you pointed out there. Now you mentioned that for India, because the target demographic uses Android mostly, we do Android development. Can you briefly explain the differences between Android development and iOS development? Why they're separate in
Sure.
the first place, and how you can cater to both?
Absolutely. So, okay. So basically, we have now in today's world of app development, we have two types of development. One is the native development we have, and other is some cross-platform technology. So, native development basically means you're building for a specific platform. So that one platform might be Android, and that other platform might be iOS. So when you're building, so what I meant by that was for the platform. So it's like whatever app we are writing in that native code base will just work on Android. Similarly, if you're writing it in Java or Kotlin, and if you're writing it in Swift or Objective C, like nobody uses Objective C nowadays, it will work on iOS. So that's the native side of app development. Other cross-platform technology. So what here I mean by cross-platform technologies is nowadays various technologies are available so that you write code once and you can see the result in both the platforms, be it Android or iOS.
Yeah, I guess that's what cross-platform development is, right? So you can write for one platform and move on to other platforms. Now, suppose that I want to build an app, okay, like say at a hackathon or maybe for a project. What are the different stages that I would have to go through? And what are the differences between these stages?
Right.
Exactly. How to approach?
Right. That's a very good question. And let's talk about the stages also first, and then let's also talk about as to what should be the right tech stack that we should be using to build our app. Right? So the stages should basically be like this. So before you build anything for that matter, figure out what your problem statement is, and based on the problem statement, decide if you want to build an app or if you want to build a website. It is not necessary that an app is a Swiss Army knife. Like, what suits your problem statement well, build that. So if it is something that you think that will be helpful as an app, go ahead and build an app. So the first stage should be identifying the problem statement and figure out you have to build an app or a website, right? After that, once you are done with that, figure out the user experience. Right? How will a person interact with your app, so that you identify as to how will the entire flow throughout the app be, so that you can build some wireframes or mockups using various softwares like Adobe XD, Figma, Canva, etc. Right? Now come to the tech stack as to what tech stack you should choose. Right? So coming on to the tech stack, so suppose if in your team you are familiar with JavaScript, right? And you are like newbie coders, you like don't know probably other stuff. So going on to native development would not be a good idea if you have limited time. You should probably go with React Native in this case, right? Or another very easy technology nowadays to get started in cross-platform app development is Flutter. Right. So yeah, before I continue on that, let me give the audience a brief overview as to what are the various technologies available in either the native side or the cross-platform side of things. Right. So when it comes to the native side of things, we have Kotlin and Java that you can build Android apps with. But if you're starting out now, I would say focus on Kotlin, because Java is now a second-class citizen for Android. Right. So Kotlin is the new way forward. And when it comes to iOS development, start with Object or Swift. Coming on to the cross-platform side of things, we have two options. One is the React Native from Facebook, and another is Flutter from Google. So if you're just starting out and you have to choose between the two, I would say, though there is no fixed answer, again, it depends on a lot of variables, but I would say start out with Flutter. That, because starting out with Flutter, it it helps the developer to get started quickly, and especially beginners, as compared to React Native. So yeah, coming back to the original point, identify the tech stack by figuring out as to what you can easily learn and easily get started with, and then build an MVP, right? So I'll come on to as to what an MVP is. So a simple example to that would be, consider any app in this world, okay? For example, when WhatsApp came first. So when WhatsApp came first, it just had the chatting feature, right? It had nothing about statuses. It didn't even have a feature to send a voice message, right? So that thing came iteratively, but the core feature of a chat application was to be able to chat. So that tells that, I'm not saying it was exactly a minimum viable product at the time. WhatsApp is a big product and it's being maintained by a big company. But identify what are the bare minimum requirements for users to use your app. Based on that, build the product, and that would be an MVP. Then give it out to your friends, let them use it, get some feedback, and then iterate upon it, and then finally release it to Play Store like you guys did for the GDSC app.
Yeah, that's a really detailed explanation of the different steps, and I think our audience can even implement these steps if they go for any competition or maybe any hackathon. Because I remember in my first few hackathons, I was not clearly aware of these steps, and I would, just start out development, and I think we picked React Native. We never drew down any designs and everything. We drew our designs on code, so it was a mess. And I think these steps helped them lay it out a bit more clearly. And now, speaking of that, what roadmap would you share for our developers out here who want to learn maybe native or cross-platform development?
Okay, sure. So honestly, like when it comes to native or cross-platform app development, there are a lot of resources available out there. Like there are wonderful courses in. Okay, so if you allow me, I'll share my screen so that.
Yeah, sure. You can go.
Yeah, I hope you can see that.
Yes, I can see.
Yeah. So I have written down like 4 roadmaps, and it's important to mention that it's not an exhaustive list. Various wonderful courses other than these exist, but to get started, these are really good ones. And after that, you can build your own products. Like after that, you can maybe try starting creating a clone so that you can learn more. But just to get a look and feel of to how to start developing apps, these courses might help. So for native Android dev, start with Kotlin, learning from Udacity, and then Udacity even has a course on app dev with Kotlin. So I have done both of these courses personally, and like wonderful courses. Then native for iOS dev, again, Udacity has a wonderful course, both for learning Swift and app dev with Swift. And then there is an official tutorial by Apple. It's around for 14 hours. Like they have multiple modules, and I was going through it today, and it's a wonderful tutorial. After that, coming on to Flutter. So Flutter is again, it's gaining a lot of popularity among developers, and I've seen like even some big brands like Alibaba moving on to Flutter for their choices. Like BMW uses Flutter nowadays, Alibaba uses Flutter nowadays, Google uses it in some of their products. So a good resource might be to get started with. It's a very famous course by Angela Yu, so you can check it out on Udemy. It's a very cheap course, not that costly. And then learn by building clones. So yeah, this is again important. Sometimes people say like, why to build already existing things, but it's okay to build already existing things and learn by building clones. This YouTube playlist is a great resource for that. And if you want to like get a quick overview as to how Flutter development looks like, so that you're just trying to figure out what you like more, this course by Udacity will help. And then coming into for React Native, again, there's a wonderful course by CS50 on like CS50 is by Harvard University, mobile app development with React Native. And I really like this course. I found it today on the reactnativebasics.com. So yeah, these would be some good resources. But again, once you are clear with the basics, I would suggest to go ahead and build stuff. You'll identify that you need a lot of libraries, and you will realize that what else do you need while building stuff. So yeah, get basics from these courses, build clones, build something, and you'll learn a lot more. So yeah, that would be the roadmap. And as Nimish said, there is no ideal roadmap. Do what you feel like is right for you.
Yeah, that makes a lot of sense, and thank you for sharing that roadmap with us. And now I wonder what opportunities there are for college students, maybe in terms of internships, or maybe they can take up a project with a professor, or out in the industry, what jobs or internships are there for app developers?
Okay, so yeah, honestly, like this goes without saying, app development has a lot of opportunities. You open your mobile phone, and first thing that you see is a lot of apps, right? We can't live without Dunzo, Swiggy, Zomato nowadays. So all of them are apps, right? So there are a lot of opportunities in the app development space, first of all. Secondly, I'll also drill down to as to what's the market share between native development, be it, or cross-platform development, right? So app development is a very big umbrella term, and like you need to figure out as to what niche you're working in, what are the opportunities in that space. So app development as a field has a lot of opportunities, but if you talk about as of today, like though Flutter is gaining a lot of popularity, it's becoming better, it's becoming more performant day by day. Like initially, there were issues that Flutter is not as performant as native apps, right? But those, like they are mitigating those issues, and even some of Google's good apps are being written in Flutter. So yeah, that being in context, I would say if you are targeting for some bigger companies, uh, I think as of today, native development rules, like without a doubt. So native development is used a lot in bigger companies, but if you're looking to get into high growth startups who are just starting to build out their product, I think because startups have limited resources, right? They would need one code base and manage both an Android and iOS. For that, Flutter would be a really good choice. And if you have your own idea which you want to take to the market, spend less time, allow more and more people to use it, cross-platform should be the way. So yeah,
Yeah.
all in all, there are a lot of opportunities without a single word. Like you go to LinkedIn and search for Android development, I think writing you'll find around 10,000 plus jobs.
True, and I think you can even find Android and iOS development jobs even at big companies. They're still recruiting native developers, and like you said, high growth startups want these cross-platform development students. And even like you mentioned that Flutter in the beginning, it was buggy, and now it's getting better. So I think just seeing the sheer pace at which these frameworks are pushing out improvements is a sign that the industry needs it. and that
Absolutely.
also proves that there are more opportunities out there.
So if you
Now-
talk about, okay. So if you talk about Instagram, right? So Instagram, people say like React Native is not that performant and things, right? But if you look at Instagram, it has probably some of the things that are really high performant app might be, like you have filters in place, a lot of features, right? But though, like, we have to keep in mind that it's being built from engineers by Facebook, so they squeeze out every bit of performance from JavaScript. But yeah, things are improving day by day, and like there is no doubt for certain use cases, still people will use native Android or iOS, but within the years to come, cross-native development will have a huge.
Right. And now that we have seen what is app development and what's web development, and about front end and back end, can you tell us in general now what's the difference between front end, back end, and which one should I pick? And as an app developer, how should I see back end development? And as a web developer, how should I see the back end side?
Right. Okay. So, okay. If you look at front end and back end, if you look at any application, any product that we daily interact with, right? Neither it's just a pure front end product, neither it's just a pure back end. You need both of them to work in sync for any app to be useful to a user in most of the cases, right? So coming on to as to front end, and so let me first segregate that, right? So majorly how, okay, for that I'll share a meme. So okay, look at this. So it says like this is the front end developer, this is the back end developer, and here it's a REST API. So REST APIs
Yeah.
are things that we use to connect back and in front end. So let's talk about the app and a website, right? So all the front end that's there, it needs to interact with something, right, for the functionality to work. So if you do, if so, you need some kind of interface between the front end and back end for them to communicate. That is nothing but a REST API. So you're building a website, you're using the REST API. And suppose tomorrow you plan that you have more and more users adopting mobile, you build a mobile app and then use the same REST APIs to build all the functionalities on mobile. So that is where REST APIs come into picture, and that's the separation of backend and front end. Did I miss anything, or should I cover it?
Yeah. I think that answers our question. And on the website, so I think it's clear that on the as a web for a web product or for a mobile product, there's not much difference in the backend. So,
Right.
you told that if
Backend
you have a
follows
web,
same.
right. So if you have a web product, you can use the same backend and build a mobile product out of it.
Absolutely. So if you have built it everything as a service oriented architecture or in terms of REST APIs, you need not write the APIs again. You just need to make those API calls from your app.
Exactly. I think we have a few questions in our chat and also our Slack channel. So I think one of the questions is, what are the prerequisites to get started with app development?
Okay. So yeah, to get started with app development, let's talk about both, right? Native, if you are getting started, let's talk about Android. Please start with Kotlin nowadays if you're starting, and know a bit of Java so that ramping up to Kotlin might help, because it's heavily around Java. So that would be a prerequisite, learning either Kotlin or Java. And when it comes to native app development, if you're going to the React Native side of things, please learn JavaScript. It will really help you out. Or if you're looking for Flutter, learn Dart. That's a programming language used for building frameworks.
Yeah, and one thing I noticed in all these languages is they're all object-oriented programming languages, right? And I think that the students in their first or second year will have a course called object-oriented programming. So, do you think that the concepts learned there can be carried forward to app development in any way?
Absolutely. See, building apps for 100 users is one thing. Building apps for 1 million users is completely another thing. So you can write code without using object-oriented programming, and apps might work. But when you scale them to 1 million users, they won't. So you need to write code in such a way that it is scalable, it is maintainable. Tomorrow, the entire point of object-oriented programming or any design pattern for that matter in general is to make your code scalable so that if requirements change tomorrow, your code can adapt to it, and you can modify your code in such a way so that not everything breaks, right? So object-oriented programming is definitely, as you asked, right, what are the basics? So OOPS concepts plus any of these programming languages to be started.
Right, and that's great. And I think scalability might not be a term that our audience is familiar with. So I guess one example would be maybe the result sites after our exams. We go to check in our results and it immediately crashes.
Right.
So I guess if you cover your basics right, then maybe you can design a better backend for such websites.
For sure, for sure.
All right, and we are getting quite a bit more questions here. So Shravan has asked, I need to develop both app and website, and I need to use Firebase as backend. So which one should I choose between Flutter and Kotlin and Java? So I guess the answer is pretty clear there.
Awesome. So as you told, you need a website also and a app also, right? And so I would suggest you go with Flutter because Flutter has an extended support for web also. You write code once and you get it on Android, iOS, and web. Though web one is like still in very early stages, so that might not be that performant as a regular website. But as I'm hoping that you'll be building an MVP for now, so Flutter should be a choice too.
Great. And we have another question from Nikisha, which says that for someone from who's not from a CS background, which programming language should they pick first?
Okay. So talking about from app development perspective, if you're not from a CS background, I always think like C gives you a great idea as to how programming works like. So C maybe, or other than that, I think it's not development. If you're just getting started, either C or Python would be a great choice to learn the fundamentals. I would not suggest Java to be the first programming.
Yeah, that's great. And I think if you have questions, you can always put it up in our Slack channel or in the chat, and we'll be addressing them towards the end of the session. Thanks a lot, Raghav. This was a really interactive session. We shall now move on to our next topic, which is machine learning, and so people will be taking over.
Supreet, you're on mute.
Supreet, you're on mute.
Sorry about that. Am I audible right now?
Yeah.
Yeah, cool. Hi, everyone. I'd like to welcome Rohit. He's a machine learning engineer at Graphene Services right now, and he was our ex-Google GDSC RIT from the years 2020 to 2021. So welcome, Rohit. So before, there's a lot of questions surrounding machine learning and stuff. So I'd like to ask you one question at the start. There's artificial intelligence, there's machine learning, there's deep learning, and there's data science. How are they different? And they all sound similar, but how are they different?
I was prepared for this question. Let me share my screen.
Sure.
All right, I've got some stuff here. Is it visible?
Yeah, we can see your screen.
Yes. So the first question, yes, there's a fundamental question. There's the first question I also asked myself. It's not a tough question. You can Google it, but let me make it quick for you. So this image should make it clear.
Sorry to interrupt, but are you sharing your presentation?
I am.
Where we link the Meet screen.
Yeah, got it. Should be visible now.
Yes. Yeah.
Yep, we can see it now.
Yeah, we can see your screen.
Okay. So there's a quick image that will make everything clear. Imagine artificial intelligence as any system that can take a decision that a human takes usually, right? So I'll give you an example, chatbot. Let's say you make a rule-based chatbot. So if the person asks weather, you give them the current weather. It's a simple rule-based chatbot. There's no intelligence in it, but it's doing what usually. So that would come under AI, but it's not machine learning or deep learning, right? Another example would be lane assistance in cars. So some cars have lane detection. If you use simple image processing to detect lanes and carry the car in the lane, then it can be classified under AI, but it's not again learning the task, right?
Okay.
Machine learning is a subset of AI where you use algorithms that learn something by themselves, that learn to take a decision by themselves. A good example would be an OCR. You would have seen the handwriting image detection everywhere. So that you can do with a simple machine learning algorithm. A simple random forest or decision tree will do it. What's different from what's in machine learning that's not in deep learning is if you are using neural networks, that goes into the category of deep learning. Deep neural networks, to be precise, you can think of neural networks for now. So any model not using neural networks would come under machine learning, roughly speaking. And then deep learning is obviously the hottest topic right now, which is using extremely complex neural networks to carry out tasks that are unthinkable of usually in terms of computer programming, right? So, for example, Tesla self-driving, that's level 3 or 4 self-driving, I believe. So it can drive you across the city or across a street by itself, or Google Assistant's language understanding, right? So even it now understands Indian accent also. Earlier it did. That comes under deep learning. Deep learning tasks are usually a lot more complex than machine learning. And data science is a quite this picture explains, right? So it involves using tools, using these learning things as tools to solve a problem, build something bigger, build something more, right? So for example, Google Assistant itself, it doesn't involve just speech recognition or just NLP. It involves a bunch of things, starting from signal processing, voice, processing it, converting it into text. Then you understand the text, you understand the context about what the person is speaking. And then you give a personalized result or whatever the result, and then you host it and making PPT is a big part of data science.
Right.
So yeah, data science is like more of a solving problem than a technical stack.
Okay. So your artificials are tools that you're using to solve a data science problem is what you're trying to get to.
Yes. And it can be non-AI also, right? If you just solve it with a statistical model, that's also data science.
Correct.
Anything involving data and pulling out information from it can be
Data
classified under data science. Yeah.
Okay. Yeah, so the next question is, there's a lot of hype around data science stuff. So what got you into data science, into machine learning specifically?
Yeah. So this GIF right here, if you can see, there's a robot car that's going on a lane, and then it detects a red signal right here, and then it stops. I saw this video in my first year. And I was like, I wanted to build something like this. That time I was interested in robotics kind of things, like cars and stuff. I saw this is like there's code running in the background. It's detecting. It looked very cool to me. I thought I'll try to build this. Now I saw what the prerequisites are. The prerequisites were a lot of image processing and AI, right? Along with obviously robotics.
Right.
So I set out to learn machine learning. Let's see how that goes. First, I took a course on YouTube by Synthex. I didn't like it a lot. There was a lot of data, plain text written everywhere. It wasn't interesting. Then I took another course by Andrew NG, that's on Stanford, by Stanford. That interested me a lot. There I was seeing things happen. And after completing that course, I mean, things got more interesting and I got deeper into it.
Okay. Okay. So, so coming back to the questions, all this seems like it involves a lot of math. So the question is, how much math do you need, or do I need to learn a lot of math to even get into machine learning?
So the basic answer to that is at the beginning, you don't. Whatever high school maths you've studied is enough. But eventually, 3-4 years down the line, when you start making sense of what's going on inside the networks, inside the models, that's when you will need maths to explain it. and intuitively understand it. So for example, today I would just use some library, TensorFlow or something, write a neural network. I don't need to do anything. 3 lines of code, I'm done. It performs well, I'm happy. It doesn't perform well, I'm like, okay, fine, something went wrong. But 3-4 years down the line, you can't say something went wrong. You want to know what went wrong and solve it. That's when you will need math, trace it back, see what's the issue. Is it the data? Is it the network? Is the network not complex enough? Stuff like that. So that's where maths will come in. And yeah, to begin with, you don't really need to worry. One good thing is Indian maths, right? High school maths is really good. We are a lot ahead of what people are taught in other countries. The integration, differentiation, calculus, all that we are taught, that's much deeper, and that's a really good advantage for us in that sense.
Great. Okay. Yeah. So working as a machine learning engineer seems like, as like a perpendicular to what other roles in the industry look like. So what does a day in the life of a machine engineer look like? How is it different than working as a web developer or an app developer? How does a day of a machine engineer look like?
I think this slide should explain not just a machine learning engineer's life, but all the coders' life. But yeah, on a more serious note, I have this, right? Yeah. So this is a very vague visualization. Do not take this as correct in all terms, but roughly speaking, this can be applied. So you start off with understanding the problem. Assume you got some data, you got some new data, right? You start off with what you want to do with the data. That's usually done at the business level. The business decision is taken as to what business goal can be achieved from the data.
Okay.
Then you see the data, see what it has and what information can be pulled out from it. Basically finding data and finding patterns in the data, right? So is it big enough? Can I correlate these things? Can I predict this? Stuff like that. Then the next thing that comes is thinking of approaches and research. So if it's a simple problem, you can either use simple maths or statistics or simple ML to do it. Then you don't really need to go deep. But there are cases where the problem is not really solvable in an instant. So you would have to do a lot of research. So for example, if you say, I have text, I want this classified as talking about a product, talking about a sentiment, or like a thing that the product does to me, right? So let's say I'm talking about, I like this shampoo versus this shampoo makes my hair silky. There's very, very little difference between those. And for a computer, it's really hard to do it. So in those kind of scenarios, you'll have to do a lot of research, read papers, find new models, find what the state of the art is, tune it, stuff like that. Then a misconception that most of the college people have, even I had, is most of the role is making models. It's not. We rarely make models. Most of the time goes in cleaning the data and making it usable, because real world data is horrible. So you'll have missing data, you'll have random stuff. No, something is off. Some stuff you'll have, some issues you'll always have, right? So cleaning data and then all that stuff. Then you go on to implement your idea, which most probably will not work, will not get the results you want. And then you repeat the whole cycle. You start with the basics, see what can be done, because you saw that this can't be done. This is not achievable. Now let's see what can be done. Let's reduce the bar, right? And this repeats until you are satisfied with your results. This can go on from a month to a year till your business goal is met. And then sometimes you optimize and deploy the models yourself. Sometimes there's a cloud team that helps you deploy it. It goes on.
Okay. So fine.
One good case study I have, not case study, but rather a scenario that happened to me yesterday itself, right? I got a data. Uh, the data was basically it was advertising data for a company and the same company's sales data. And we wanted to find correlation, seeing which channel of advertising, for example, phone calls or WhatsApp messages, SMSs, which of these are really affecting the sales. And the graph you see here on the left is the blue line here is the sales, and the red line is the phone calls. So there's no way you can say that there's a correlation between these, even though you can see a very slight correlation, but the information is too low to conclude that there is any significant correlation. Now what you do? We can't get more data. Now what you do? So these kind of things happen a lot in the industry, which we don't do in college projects. College projects, we take up data where it's known to work. Here, it's the other way around.
Okay. Okay. Yeah. So coming to the next question. So now that we know what the role of a machine learning engineer entails, could you like give us a roadmap, something that we could follow to get onto the track of learning machine learning and getting good at something like this?
Okay. Again, as the other Raghav and Nimish, both of them suggested, there's no clear roadmap. But this thing, I think you can take a screenshot of this. This is a very vague idea of how I look at it. The first prerequisite is if you want to go far in it, is liking maths. Not just in the basic sense, you don't want to put formulas on the paper and write it down, but rather visualizing maths. How, let's say, how a matrix transform works, or how spaces work, how statistics work. If you have never seen something like that, check out this channel, 3 Blue 1 Brown on YouTube. He does an amazing job of visualizing math. If that interests you, if that somehow makes you feel like math is more than just numbers on paper, then yeah, I think you can definitely try machine learning. But if you still hate it, if you still don't like playing with numbers, maybe machine learning will look fun at the beginning, but then as you go deeper, it would be a little more boring, right? The second is, are you bad at UI design? It's just for a joke. So I was horrible at UI design in color. So I tried web development, then I saw how horrible my website looks, and then I just like gave up. Then yeah, the whole world mostly begins at this course, Machine Learning by Stanford on Coursera. Highly recommended. It is taught by one of the greatest researchers / pioneers of machine learning, Andrew Ng. And yeah, it can be a little intimidating at start. It involves, like, it starts off with maths itself. But as you go and as you understand how things are happening, I think you should get a hold of it, given that Indian schools have taught really good maths. And yeah, if by the time you complete the course, if you find it interesting, you can obviously go deeper. There's a lot of stuff. YouTube is I believe the best place to find how to go about things.
Okay. Yeah. Okay. Now I have another question to ask: is what are the opportunities like as a machine learning engineer right out of college? Like I've heard that you need like an advanced degree or you need a PhD or something like that. What are the opportunities available for someone who's just out of college and who wants to pursue machine learning as a career? What would you say?
Here, I'll be honest with you. For what I saw on our campus in my year, there were no explicit machine learning engineer roles.
Okay.
There are possibilities that you are hired as an SD and then you're later put into the AI team or something. But for me, I didn't see any straight up machine learning engineer roles on campus. Okay. Off campus, very few people hire freshers, especially fresh out of undergraduate, right? out of masters is a different thing. But undergraduates, there is little. But one thing is, as you gain a little experience, things go much better. There are a lot of opportunities out there for a little more experienced people. But yeah, I wouldn't say it's impossible. I would say it's just a little harder. So if you are really interested, then obviously you can make. But I'm just being honest to not get your hopes up and then see that the right. And in research, AI is the hottest topic in research right now, I believe. In general, research is a lot less popular than jobs, obviously. But the probability that you'll find AI research divided by the probability that you will find research is quite high. So basically, out of all the research, there's quite a bit of AI research going.
Yeah, research. Great. Yeah, so we've got a few questions here, and the first one is PyTorch versus TensorFlow, the battle of the libraries. Which do I pick?
If you are beginning, take a TensorFlow.krs. It'll make your life easier.
Right. Yeah.
You don't really need PyTorch until you go to really complex models which are not directly available in KRS. For example, some sort of networks which involve more than just neurons are not available in KRS. That to go to either the core TensorFlow or core PyTorch. In the industry, PyTorch is usually more preferred in the newer companies, whereas TensorFlow is like the industry leader, right? It's like the Angular that has been there from a long time. PyTorch is a little new, it's hot. But don't worry about libraries, just use KS for the beginning. At least you will need at least 2 years into the field before you will need something that Keras doesn't offer. And by that time, you will have an opinion on Keras or TensorFlow. So don't worry about this.
Okay. So we have one more question, which is, should we go into the depths of these frameworks and build our own models, or should we just stick to fine-tuning pre-trained models and get good performances and just show it off on our resumes and for jobs and stuff?
I think this slide summarizes what you're trying to ask, right? Don't do it to show it on your resume, but do it because you are enjoying it. This goes for any field. You will not go really far because you will lose interest if you're just doing it for the hype or for the resume, right? It's not necessary that you have to have ML on your resume. It's definitely not. But do something that you enjoy and are trying to answer that question. Fine-tuning models, see, it depends on the use case. If you have, let's say, 1,000 images of handwritten characters, that is not enough data to train a deep learning model. That's when you will go with transfer learning, which is taking pre-trained models and tuning them. Whereas if you have the same data, but for 1 lakh images, I mean, if the same thing for 1 lakh images, you would choose to train your own model because that would be a lot lighter. Pre-trained models are like 500 MB, 1 GB, whereas your own network would be around 2-3 MB. So it depends on the use case. Usually in hackathons and all, pre-trained models help because you barely get any data and then pre-trained does a great job. So that's an advantage of those.
Okay, cool. Thank you so much. I think if there are any more questions, you guys can ask it in the Slack channel. Rohit will be there to answer your doubts. So thank you so much, Rohit. I think we'd pass it on to the next speaker. And
sure, thank you.
Okay.
Okay, now that we got some cool insights into machine learning, let's jump into another track. One topic that's been floating around everywhere, and you too for sure would have heard it somewhere, is blockchain. Terms like decentralization, cryptocurrency, DeFi, etc. are a few terms that generally pop up when you search blockchain. But to know what it is and what opportunities can it present when you dive into it, we have with ourselves Aditya Gupta here. He works as a blockchain engineer at BrahmaFi, and he was the GDSC lead for the year 2018 and 2019. More than me, I guess it would be better if he introduces himself. So, over to you.
Thanks, Jan. Not there for long introductions. So yeah, I think every speaker in the panel is an alumni of RIT. So great pleasure to be here. And more than a blockchain engineer, I'm just a student like you. Just passed out way too early.
No, it's a great pleasure to have you here and get some insights on what the blocks are and what blockchain is. So I just dive into the main question here and ask, what is blockchain and how does it work?
Okay, before I start, I'll just take a little bit of your time to know my audience because I don't know if I'm talking to my grandpa who barely understands technology or to a Gen Z kid who is all on to all the latest platforms. So I don't know, people who are awake, just type in what you think blockchain is. Just give it 2 seconds, give it 5 seconds, type whatever you think is it in the chat, and then I'll get an idea of what's your current understanding, and that's better for me to answer your queries. And also lets me know how many people are really sleeping versus listening. Okay, chain made of Lego blocks. Nice. Blockchain is a decentralized ledger. This guy's serious. A big linked list. I like that. I really like that. What else? Two of them are just speakers and organizers. So no one's. I don't think we're going to get answers today. Chain that is blocked. Okay. Something that helps crypto stays on top of the list. Data storage. Okay, some of the answers are meaning, some are really serious. A decentralized network. Distributed ledger, record books with a strong lock. Makes sense, makes sense. So it says free money. Yes, it is. Mark my words, it is. So, type of a shared database, right? Starting to think decentralization is key here. Kind of, yes. So, okay, blockchain is, let's take it to the very basic. Blockchain is just a chain of blocks. Now, it's key to think what is the block here. A block is just let's say, a bunch of data.
Sorry to
So you
interrupt,
have,
Aditya, but there's some static happening with the mic.
one second, please. Can you hear me better?
Yeah, much better.
Okay, awesome. So, yeah, I just saw my iPhones are not connected. Anyways, so I was continuing on the blocks. So blocks essentially just have data inside them. Now the data is what makes the blockchain so unique is that every piece of the content of the data is validated. It keeps on adding data. So think of it like a timestamp DB, if you know about that. Time series database where every data that's added has a particular timestamp to it when it was added, and add a layer of security on it, saying when someone adds a data, let's say you see an SQL database or any kind of database, there's some data, there's some names, there's some addresses or whatnot, but you don't know who added them or when they were added. Blockchain just provides that service where this person added this data on XYZ date with this much uh, money. So when you add data to the blockchain, you just spend a little bit of money to do that. That's the part which runs the blockchain. It's a self-sustaining ecosystem. You don't have to beg some corporation to keep it running. So it essentially comes down to it's an game of economics. When you use Gmail, you use YouTube, it's free to you because someone is playing ads or someone is making money through some other ways. Blockchain doesn't have that kind of a monetization system, so it is self-sustaining. And what that means is it's an economy where if I want to make a transaction or if I want to save the data, verifiably. I need to pay for it. And people who run the blockchain, you know them as miners, who buy all our graphic cards and keep on mining to create new cryptocurrency. So that's yeah, they get why they buy graphic cards is so that they can mine this blockchain and they can get paid to mine this blockchain. And we users who use the blockchain are actually paying them. It's essentially, a trustless system because there's a lot of cryptography involved. I'll dive on that later, but does that answer your question on how blockchain works? Or did I have more
It
questions?
certainly does for me.
Okay, great.
Knowing this basic part, what can I build with it and where is it used in general?
Hmm. See, that's a unique question because imagine right now it's 1997 and people have just started building websites, and one of the first websites was radio on the internet. Now, why would you use it? I don't know. People did like it and people funded it a lot. So, what can you build with it essentially is yet to be seen. I can tell you what is being built right now, which is cryptocurrencies, NFTs, DeFi. DeFi is decentralized finance for people who don't know. By the way, I work in a DeFi project. So, what you can build with this is okay, let me go for a real world application. Now, let's say there's no trust between parties. Um, let's say I'll take a real case. There's a company called Everledger. So they are providing blockchain as a service to the diamond industry. So diamond industry has a lot of players. You have the mine owners who actually own the mines where diamond is mined. Then you have the miners who will actually mine it for you. You have the carriers who will supply this diamond through the supply chain to, a refiner who will actually make those diamonds, like cut those diamonds, make them usable. And then those refined diamonds will be sent to the jewelers. There are a lot of moving parts and these are high value goods. So to track their supply chain and track the existence of each diamond from the mine to the jeweler's hands, they're providing blockchain as a service for that. So it works in a trustless verification service where each party who owns that product at that particular time. So let's say I'm a miner, I own it as in it's in my hand right now. The diamond that I mined is in my hands, will be stored on the blockchain saying I got a diamond, what this much grams at this timestamp. Now, when I hand it over to the shipment, like say FedEx or whatever, it will be stored on the blockchain saying this person has signed. It's similar to when you accept a courier, you sign on the paper, right? That I've accepted the courier. It's just making it cryptographic. And since it's all, I have my private key, I have my public key, more like, it's my account on Gmail or whatever. So I'm signing it using my account, and that means that I have accepted responsibility for this product. And this goes on through the supply chain until the goods finally end up with the customer. So that blockchain also helps us track, this my diamond was mined from here in environmentally good conditions and socio conservative conditions, and also it's not stolen or the diamonds don't get stolen. That's probably one of the good real world cases of blockchain at this moment.
Was a real cool real world example for us to gain some insights.
Yeah.
Like everywhere there are like coins called Bitcoin, Ethereum, Solana. Like how are these different from one another, and like how are they connected to blockchain as a whole?
Yeah, so that brings us into different types of blockchains because okay, uh, so there are two types of cryptocurrencies, native and tokens. Yeah, a lot of people don't know this. Native cryptocurrencies are actual blockchains. Tokens are something else. I'll explain that later. So native cryptocurrency, let's say Bitcoin. Bitcoin is just a blockchain saying, I have a blockchain saying at this block, 10 people hold 10, 10, 10, 10 Bitcoins. That's what I started a blockchain. Now, every block that keeps adding to this blockchain will have some transactions on it. And the first transaction, I sent you 5 Bitcoins. So the new block will say, I have 5, you have 15, and so on. So this block continues. And in each block, also, people who are mining get additional Bitcoins. So let's say 5 people have started mining, they get 5 Bitcoins each. The chain goes on to make it a self-sustaining system. And I coded that, after 200 years, no more Bitcoins can be mined. Mined in the sense people who are mining it won't get any free Bitcoins now. So Bitcoin is that currency which is running the network. I'm incentivizing the miner to get paid in Bitcoin to run the chain. Meanwhile, I'm storing the transactions. Now, this cannot be banned by any government. That's why it's a pet peeve of a lot of governments. It cannot be stopped by any particular government. It cannot be censored. And this and code is the law in blockchain. So since someone coded that it cannot, the total supply of Bitcoin will only be 21 million Bitcoins. It cannot go beyond that unless they change the code. And even to change the code, every miner in the world has to agree on changing the code, which is very difficult to do. Because if you try to increase the supply of Bitcoin, it will decrease the value of Bitcoins that they hold. It's quite difficult to do that. And essentially, what happens is you end up having a system which is as far as now, Bitcoin is running since 12 years. It's self-sustaining. Nobody's paying them to run Bitcoin. Miners mine because they have an economic incentive. People transfer Bitcoin because they have an economic incentive of not bypassing the government or bypassing territories. If I want to send some money to a person in USA or Germany or Canada, it's easier for me to do that on Bitcoin rather than through traditional banks. Takes way less money for me to actually send the transfer. It takes way less time. It reaches them in like 2 minutes, 5 minutes, 10 minutes, as opposed to 2 working days or 5 working days. So yeah, it's kind of so there are a lot of blockchains now. Think Bitcoin but bigger. There's Bitcoin, there's Ethereum, there's Solana. All of these are their own blockchains. Each, like, there was a different set of miners mining their transactions, people making transactions on these chains. Ethereum and Solana are kind of smart chains where you can put your own code on them if you want to run, like smart contracts they call it. So now let's say someone told Doge is blockchain. So Doge is not a blockchain. It is just a token running on a blockchain called Ethereum. So native tokens, what I told was native tokens are Bitcoin, Ethereum, Solana, because they own their own blockchains and people are mining them. All these other they're called actually cryptocurrencies. And then there are tokens. Tokens are just small distributions of a cryptocurrency running on a bigger chain like Ethereum. So most of, like, 99% of the cryptocurrencies that you find are essentially tokens running on Ethereum or Polygon or Solana. So yeah, when let's say you want to invest in Doge, right? That's a bet that you're doing on the project that the project will be good. But let's say you buy Ethereum, that's a bet on the whole ecosystem that the Ethereum chain running all these programs will do some good later. Yeah, so that was my answer on what cryptocurrencies are.
That was like a certainly good answer that it made me understand everything as a whole completely. Like the next question is something Nimish mentioned briefly about, and I guess some people already know about it or just have an idea about what is Web 3.0.
Web 3.0. It's kind of, let's say. So if you were a kid in the 1980s and you are running you got your first computer because you're not in India, you're somewhere outside, and you just connected to your DSL modem. At that time, Google didn't exist, Facebook did not exist. Your email services, your messengers, they did not exist. There was a service called Instant Messenger. And how Instant Messenger used to work was you had to keep your computer on 24/7 so that it could receive a message. It's not like you have Gmail, you open it the next day and you have your messages. If your computer is open, it receives the message. If it's not, the person cannot send you the message. And that, okay, now think about it. Why that happened is because there's no person hosting the server. There is no company called Google hosting their own database and servers where you can save the message and you can read them later. It's all happening peer to peer. I sent a message to you, it goes from my machine to your machine. There's no machine in the middle. I own my data, you own your data. Now that was Web 1.0. Web 2.0 was where all these big monopolies got created and they started holding our data for selling it or monetizing it. Web 3.0 is kind of like fixing that, giving your control back to you. It's as simple as that. All decentralized applications, or which claim to be decentralized applications, are built around the idea that you own the data.
Good that we can understand Web 3.0 better. Now, rather than about blockchain, let's talk about us and learning it. So, what skills does one require to know and work in the world of blockchain?
It's a difficult question because okay, I'll take 5 minutes, but I want to give you my story about how I got into it.
Sure, that's
So yeah, in 2017, I was a teenager college student, wanted to make some money, so I got into crypto trading. And from there, I went into Ethereum, the smart contract side of things, how to develop on this because I was a keen developer. Before that, I used to work in GDSC, like DSC RIT and all that. So I had a sense of good development. I made websites, I made mobile apps. I even tried my hands on ML. I didn't like it because uh, Rohit's problem. You fuck around a lot to get your data. I didn't really like it. So because my data was always shit, so I left that. But yeah, I eventually stumbled onto the blockchain side of things. Then I went to a lot of hackathons and I learned a lot from my peers around them. And I think in 2018, yeah, I made a cool blockchain app in a hackathon. They really liked it. They wanted to help me make a product out of it. So I went along and basically we founded my first startup, which we raised some money and we went to Hong Kong. And that was in my fourth year. So just a side note, cool thing about Ramaya is I convinced my teachers to let me attend this 3 months event in Hong Kong and please give me attendance because I don't want to skip my semester. And they were cool, they agreed. So I don't think a lot of colleges allow you to do that. Finally, I come back from there. I see that the app is not going to work because of some technical limitations. But I finally have my first entry into web sales, met a lot of people, and made a lot of connects. Then I graduate from college, but I still, I'm in the ecosystem. At that time, I graduated in 2019, and there were absolutely no jobs in Web3. People didn't know what Web3 was, at least in India or Bangalore. And blockchain was like a buzzword which people used to throw around randomly. So yeah, I got a regular job, but I kept freelancing on the side. And finally, I think in 2020 it took off really well. And 2021 was actually in 2021 it took off really well. And I kept freelancing on the side and finally got into the whole ecosystem of blockchain and decentralized apps. But again, as Rohit said, learn it for fun. Don't get into it if you don't like it because it's decentralized, dude. You don't have one server, you have 500 different servers. You have to connect with all of them. It's not easy. Uh, I'm not discouraging you. I'm just saying if you only like it, then try it out. If you want to get into blockchain development, do anything like go to YouTube. If you like NFTs, create your NFT. If you like cryptocurrencies, try to create your own cryptocurrency. And that's kind of my learning process. If I like anything, I try to build it, or if I have a problem, I try to build it. I don't believe in roadmaps, like Nimesh said. I don't think that's a good way to go. It restricts your learning.
Yeah, that's a great perspective, to be honest. Since you mentioned YouTube and everything else, like, what do you think, according to you, are some good platforms to learn and understand development of blockchain and stuff related to it?
YouTube is good. YouTube has a lot of tutorials. Then you have paid courses on Udemy and Coursera. Uh, Depends, right? So it's kind of like a little bit of, let's say, web development. Not exactly web development, where the web development is, let's say I'm developing a website. So as the speakers told earlier, you have front end and back end. The back end is the one which actually hosts the website, and front end is what you see on your screen, the looks of the website. So in this case, if you want to go into blockchain development, the blockchain already exists. You don't have to create your own Ethereum again, or you don't have to create your own Solana again. By blockchain development, what they mean is build apps on it. So just like you have mobile development, right? When you do mobile development, you don't develop your own mobile, or you don't develop Android or iOS. You develop apps on it. Same happens with blockchain development. It's actually pretty simple. If uh, mm, I'll link a few links actually in Slack. That would be a better way for you guys to just get to know about
Yeah.
the platform in general. Yeah, Rohit's asking, do you think quantum computers or other breakthrough can break cryptography? That's fundamental to blockchain. Yes. Yeah, that's a risk. That's a never lasting risk. You might not even know. The US Fed might already have quantum computers and they're already reading all the private transactions. But yeah, if they actually break through it, yeah, it will crack cryptography, and then not just blockchain, any kind of encryption is dead. So private communication in this world is dead. Then you can go back to sending telegrams or something else.
Damn, that's some cool insights on everything related to blockchain and how we can grow within learning from it. So, with that, I would like to thank you, and it's been a great pleasure to have you here and know what blockchain is around it. So,
Thanks,
now I
Jay. Nice to
guess
talk to you.
it's a pleasure. Now, I guess I'll hand over to Spurti to talk out some miscellaneous questions and uh, uh, address some questions being asked in the chat.
Yeah. Hello. Am I audible?
Yep.
Yeah, you.
Yeah, so these questions are miscellaneous and not specific to any one field. So I request all the speakers to turn on their cameras and answer the questions, whatever they feel it is right to do. So, can I start with questions? And I'll take up some from the chat boxes as well. The first one is, how important are CS core concepts to choose any domain in tech field?
I'll say extremely important.
Okay.
Yeah, I mean, fundamentals are important. Yes. Be
So,
it CS background or not, but you will need the fundamentals.
okay, like what to focus more on when it comes to CS core concepts? Like there are computer networks, operating system, memory, computer organization, theory of computation, etc., etc.
Though all the subjects are equally important, but I would say object-oriented programming, design patterns, compiler design, operating systems, computer networks, is how databases work, database internals, computer
You listed
organization.
everything.
Everything.
whatever they teach you till the third year. Fourth year,
Okay.
it's all electives and optional and high level stuff.
Right.
No, but if you want to start, I think just learn programming language and then beginning. Further, you can like obviously learn in depth as you go.
So, like, if we suppose we choose one field, say I choose web, and I want to do CS core concepts. So, what would be like better? First do the CS core concepts, then jump to web, or do them parallelly?
Um. Okay. So, in my opinion, it's not like they have to be done concurrently. Okay. It's not like complete this and then this starts. So, if you're doing web, it's fine. Like as in you running web, so you don't really happens like what is going on in the background, right? Like TCP/IP packet and at every layer of the OSI model. And computer networks are like, oh wow. So you can learn it in
Yeah, so
parallel.
you don't need to wait for your core fundamentals to start building stuff.
Okay. Okay. So, moving on to the next.
When these things are taught in college, learn it properly. It's the easiest, quickest way to learn if you
Yeah,
don't want to spend
listen
time
to
on
your
what you're doing.
teachers when they actually try to teach you.
Okay. So, attending classes is important.
Or read books.
If you want to learn it yourself, but in that course itself, just finish it off.
Yeah, during the course, just
Time.
either hit the books or listen to the teacher. Grow your knowledge regarding the core fundamentals. You don't need to wait for them. Or like you can start building your websites, apps right now. You don't need to wait for any of them to start. But whenever they try to cover it, just listen and expand your knowledge on the how the things work deep down.
Okay. So you all mentioned about participating in hackathons. You all have won so many hackathons. So can you like brief out us how will these hackathons help one in approaching and building their career or learning new stuff?
Okay. So like I don't know like how it'll help in building the career and things, but like when you go to the hackathon, right, you realize like when you're building something like I built it. Secondly, like whenever you see any products outside, like if you have been to a hackathon, you can identify like why did they develop this, and like why did the marketing team think like that, or why did the user experience designers think like that this should be this way. So that teaches you a lot of real world software. In my opinion, like that is why you should go to hackathons. How it will help in career or something, like maybe it'll look good on your resume.
Yeah, no, I think you are the question whoever asked this was quite focused towards career. I don't believe you should focus on your career right now. You're like just starting college. Focus more on learning things. I mean, I used to go in hackathons just because of free food, and then yeah, see, that's the hostel attitude. So once you go there, you finally build something, and then you feel good about it because in your let's say programming assignments, they will be like find the Fibonacci sequence or compute the square root of something. Now that done in C or C++ or Java is of no value to me. Whereas if I have an app or website running on my phone that I can show to my friends, that has immense value in my hand. And just going into hackathon and building something is good for your learnings. You are building something which will benefit you, or you can maybe monetize it later. You can build an organization around it. That's up to you. Or if it was just a side project, that's also good. If you think everything in terms of how it will benefit my career, I don't think that's a good developer attitude.
Okay. Say teams are working on a project, so how can they collaborate between them and work on that?
Yeah, so like actually this is very important. Okay, like in my opinion, like if you have a great team, like you're all set to win a hackathon. So like how to collaborate, identify people in your team with varying skill sets. Like for example, if somebody is good at backend, there needs to be a if a team is full of backend people or full of front end people, you can't really build a really great product. But if you have people with varied skill sets, some front-end people, some backend people, some ML ninjas, Rohit sir, so it'll be like you can get build a team with people of varying skill sets.
And accept that there is one person who will do 60 to 70% of the work. That's how it works. Team projects are always that. It's fine. Try to be that person who does most of it. You'll learn the most.
Even if you don't do most, at least check how they do it, or try to learn how they try to do it.
Okay. Now, like, what should one focus on keeping placements in mind?
Sir, if your target is bigger companies, data structures, algorithms, without a doubt. But learning development will help you when you go inside the job. If you really are like, if you have that entrepreneurial spirit and you really like to build great things from scratch, doing development will help you a lot to get into good startups. They don't focus on DSA much nowadays. So, yeah. Like, this was a very honest answer, but
No, I 100% agree that was the most pure answer I've ever heard. If you want good companies, don't even join this organization or don't even join this club. Just
yeah,
go to Lead Code, HackerRank, and do that 24 hours a day, and you'll be in Google or whatnot.
yes.
But yeah, if you're a hustler, then you should know development. It helps you a lot.
Yes.
Okay. And talking about development, like, what does one focus more on? Like, is it competitive programming or projects? Like, this is always a debatable question. Is it CP or projects?
Wasn't it the same question that I just answered?
Yeah. Like,
Having this question since I was in first year.
so again, the
I
same
asked
thing,
this
like
to Aditya.
CP, DSA, CP/DSA/ any kind of those data structure programming. If you want to get into big companies, do that day and night, and you'll get it.
Is that the only goal?
Yeah, that's debate.
That's something you will have to ask yourself. Is that the only goal? Because what happens after you get into big company? What then? Right? That's also something you'll have to ask.
Okay. And when it comes to open source, what is it to be an open source developer? How to start contributing to open source projects? How will I find a project of my own interest?
I think the right person to answer this, Nimish, is not here. Uh, Honestly, I have not done much open source. Like I just so yeah. I think like the start. So the usual advice people give is like there are some websites you can filter it by good first issue. So if that good first issue is something easier to get started on any open source project, try setting up that project and then solve the good first issue ones. Yeah. Maybe.
What Raghav is talking about here is in every project Git repository, there's something called issues that are raised by the developers themselves or the product creators themselves, and expect or not expect, but rather allow outside people to come in and solve those issues, which by which they are contributing to the project. So those are called issues. So if you go to any big repository, you will to the GitHub, you will see issues. There will be a quite a few. You can pick any of those and solve it. Uh, that depends on your how much you understand the project and all that. Yeah.
Okay. So when it comes to learning different technologies and growing expertise in them, what is the minimum number of technologies, or would you like recommend by several domains at once or one after the other? Like what would be the flow in them?
This is a question I had doubt about engineering and even today, honestly. So I say like uh, it's like try if you want to try out, but make your niche in some one thing. So be a kind of a it's called as a T-shaped developer. Be very good at some one, then try out whatever you want to understand.
Okay. And in the chat box, there is one question specific to blockchain that would be directly to Aditya. So what Muskan is asking is, does do freshers have a good scope in blockchain jobs, or they prefer masters or experienced candidates?
Interesting question. So, to be frank, blockchain as a technology is hardly 11 years old. And on top of that, programmable blockchains are not more than 6 years old. And the organizations hiring around now, so that's mainly decentralized finance, NFTs, cryptocurrencies, exchanges, all of these organizations are not more than 3 years old. So if you try to go find a like if you try to even if I today try to do a master's in blockchain, there is no college who will offer a master's course in blockchain or PhD in blockchain. Hardly like one or two colleges in the whole world. So yeah, it doesn't matter where you're coming from, as long as you can build stuff or you know the ecosystem, you can join. Even like I've seen really kids working. Like there was a guy around 15 years old, he's running his own blockchain company or whatever. And not one, like there are a couple of people, there are multiple instances where people just learn the technology and get into the ecosystem. There's no really requirements even for a computer science degree for that. Because the space is so new.
Okay. So do we have like,
Yeah, okay, good
so
scope.
that's all.
So, no, one second. I just read the question. So, masters or experienced candidates, I told you, like you don't need any professional degrees. And they ask if there's a good scope. Yes, there's an extremely nice scope right now. It will continue for at least the next 5 years.
Okay, nice. And when talking about choosing a field in all these technological domains, is it like always good to go with the buzzwords like AI, ML, blockchain, web app, or is it good to like choose something that is not really common, like low level coding or compiler designing, computer networks, etc.? And if someone is choosing those, what are the career options in them? This is my personal question.
Extremely good. So I have a friend who works in ARM Technologies. So yeah, he's quite sad right now because he was expecting a lot of Nvidia stock if the acquisition went through. Uh, yeah. So, but yeah, he has a great career prospect because he's working on some really cool stuff, and he has a niche domain. So he's not easily replaceable. He can command high salaries. He's yeah, I think he's just trying to switch right now, and he's already getting like 70-80% hike on top of his previous uh, base pay. It's simply because there are not a lot of engineers in this field and it's very niche. So if you want to go into some such niche fields, because you see compiler design, low level coding, manipulating bits in your socks, they're never going to go away. As long as we have machines, these fields will stay there and the engineer demand for engineers will stay there. Although less, the demand will still be there.
Increase more in the years to come, I think.
Yeah, everyone is now making their own socks. Like after Apple started, now Google, Samsung, everyone wants to make their own chip designs. So yeah, demand is actually increasing. Even if you are in a field which doesn't have an immediate demand, you should pick a niche because ultimately in the end, if you like the work, your life will be way easier. You won't feel like working every day, and that's what immensely makes it more easier to work on.
Right. And one more thing, like from these kind of domains, switching to web or slash anything of that sort is very easy,
Hmm.
but other way around is tough.
Yeah. If you think at the end of the day, even if you go all in and it doesn't work out, you can easily switch and get a normal job.
Just do data structures after that.
So how quickly should one start doing data structures, keeping placements in mind? And yeah,
See, 1 month to 2 months is
digital
also
forensics
fine.
and
People
all.
can also prepare for 3 years. Similar, ask yourself,
Why?
how long did you
Sorry.
prepare for the JE or whatever your exam was, PUC exam? You could be studying for 2-3 years, or you could try that in half a year, 3 months, whatever you prefer. Like, depends how dedicated you are. Yeah, Rohit, go ahead.
There was a guy in our college. He started CPA in class 9th. That's how
Sad
bad.
life. Sad life.
Okay, yeah. There is one heads up to all the students out there. If you want to start practicing CP, there is a contest by Newton Schools. You all can go check up our GDSC app and take part in that, please.
Sorry.
Yeah.
Sponsored
Yes, the
advertisement in
sponsor.
queue.
Oh, nice. We have sponsors.
Yeah.
See,
So I
this is the
think
hustle
that
spirit. They monetize GDSC.
yes.
Right.
We'll get some money.
I
Yeah,
don't
yeah,
know.
we got,
That
we
that
got,
goes
we got.
against their business model.
Yeah. So that was all the questions from our side that did not like specifically belong to any domain. So if you people have any like uh 2 cents of yours, please give it to us.
लाइफ में ये सब टेंशन वेंशन नहीं लेने का. जॉब वॉब चलता रहेगा. Find peace in life. Mind peace.
Okay. That was
Well,
a life lesson.
I'm not. I'm joking at the same time, not joking. Basically, there's more than just tech and college and job.
I agree to it. And secondly, I have a lesson like which I learned the hard way. Like I always used to think like sharing your achievements on LinkedIn is bragging, etc., etc. It is not. Like share things on LinkedIn, it pays off is what I have seen. So yeah, like nowadays, like all I'll say is like share things on LinkedIn doesn't matter. Like don't share memes, obviously, but yeah, if you win anything or anything, always share on LinkedIn. It really helps.
saying larger than life advices.
Yeah.
You all are in Ramaya, you'll get placed 100%. Don't worry. That's my advice.
Okay. Yes. So yeah, that was all on our part, and I'd like to thank you all from the entire team for taking your time out from your busy schedules, giving up on your weekends to enlighten us with your words. Thank you so much. Well, we will keep pinging you if we want any other help also. So yeah,
Sure,
that was from our
you made
part.
us join Slack, so fine.
Yeah.
Okay, then thank you, everyone.
Okay.
Thank you
Great
for hosting
discussion.
this
Thank
event.
you.
I learned a lot from all the other speakers. Thank you.
Same. Especially Aditya Bhaiya, Rohit sir, Nimish sir. Like all three are the ones.
Sure.
Sure. Thank you. Bye bye.
Thank you.
Thank you. Yeah, हो गया